So here we have a complete combustion of ethanol, so C2H5OH, and then it's combined with O2, and then it's going to produce carbon dioxide, so C double bond O twice, plus H2O. Now we want to make sure that we balance the equation as well. So we're going to put a 2 in front of the CO2 and then a 3 in front of the H2O. And here's our Lewis structure for our complete combustion of ethanol. So we're going to look at each bond that's available. So first we're going to look at the CH bond. There's 1, 2, 3, 4, 5. So 5 CH bonds. And that will give us 5 times 4, 11. And in this case, it's going to be positive because we're breaking bonds. So we're inputting energy into the system, or it's an endothermic reaction. So it's going to be positive. Then we're going to look at the next bond that's available, which is a carbon-carbon bond. And that would be 347. And that will also be positive as well. I'm a little bit slow on this video because right now I realized my answer key was wrong. So we'll just wait a little bit. But there it goes. Carbon-carbon. And that has a delta H of 347. The next one is CO, and that one has a delta H of 358. And the last one will be OH. Technically, there is OH on the left side and the right side. So some of them can cancel out, but since they're not the equal number, it's just not worth the trouble. So it's easier just to add it all together. So we're going to add them all together, and we should get 4,701. Oh, I forgot oxygen. So I didn't add oxygen yet. So that's for just ethane. And now we need to do oxygen. So it's an O double bond O. I don't remember what I was doing in the video. I think I was just still staring at my wrong answer on my answer key. So there it is, 3 double bond O, and that is 494. And in this case, we have 3 of them. So we're going to multiply by 3, and it's still positive. Plug it into our calculator, and we should get 1482. And then when you add it with 3219, you should get 4701. Now we're going to do the right side. And the right side we have C double O bond. And that is 799. But we have 2 bonds per carbon dioxide, and we have 2 carbon dioxide. So 2 times 2 gives me 4. 4 times 799, in this case, negative. Because remember, this we're breaking, or we're making bonds now, so we're gaining energy out of the system. So energy is coming out. It's exothermic, so it's negative. Then we're going to do a OH bond. Oh, I did that one first. Now we're going to do an OH bond. We have 2 per water, and then there's 3 waters, so that's 6. OH bond is 459, and again, that's negative as well. And then when you put that in the calculator, we get negative 2,754. So the total energy released from the bonds formed on the right side is going to be 5,950. And then when you take the sum of both sides, you get a delta H of negative 1249 kilojoules. And part C, what we're going to do is, now what happens if we had 29 or 24 grams of ethanol? We want to use conversion of units. So first we want to make sure that we change it into moles. Oh no, it's not showing on the page. Let me see if I can adjust it. Nope, it's not showing. Okay, so we're going to convert it to moles first, so it'll be 24. And then the conversion is 1 mole over 49.08 grams. So that is the molar mass. You can't really see it on the bottom here. And then you have 1249 kilojoules per mole. So that's that part. And the last part, we want to change it into calories. So 1 big cal is equal to 4.184 kilojoules. So unfortunately, we can't see the bottom there. It got cut off in the video. And that is equal to 145.9. So when you round it off, it's 146. So unfortunately, you can't see these again. 24 grams, you're going to multiply with the ratio moles over the molar mass, so mole over 49.08. Then you multiply it with the amount of energy per mole of ethane. And since in the equation it's ethanol, 1 ethanol makes that. That's what happens. Or you multiply by 1249, and then you convert it into calories. Hopefully that turned out okay.